All right, so in this video, we're going to take a look at mean and standard deviation, this first section of this stats exponents log unit. So the first thing we're going to talk about is continuous versus discrete. So discrete data is often called countable data. It's like things you can count. It can only take certain values, such as generally its whole number. Right, for example, here it says people at a football match. So that could only be a whole number. You can't have this many people at a football match, right? Like you can't have that much of a person. So that's an example of discrete data, right? Discrete data is countable. It's whole numbered things, right? Generally, it's applied to the real world. And then we have things like continuous data, right? And these are usually things that are measured, and they can take any value. Such as height, right? Like you don't suddenly grow from 1.45 meters to 1.46. It's a slow progression, right? You could have something between those. You could have 1.455, right? And so measured data is continuous. It can take on any value. It doesn't have to be whole numbers, right? So the difference between discrete and continuous is important. When we talk about the measures of central tendency, so if we want to measure the middle of something, we want to figure out what's happening around the center. We have three ways to do that, and they're things that we've been doing for a long time. We have mean, median, and mode. And we'll define each of those in a second. So for mean, you sum all the data, so add it up, and divide by the number of data values. Right, and so what that looks like with this sigma notation is this is pronounced X bar, that's how we say it. This is the symbol for mean, and it's pronounced X bar is kind of the bar on top, that's why it's called that. This up here says the sum of all X values, right? So add up the X values. And this N is the size of the data. Right, so here for this one it says find the mean. Well, X bar would be 10 plus 12 plus 17 plus 24, and we divide it by 4. Right, add them up, divide by the number that there are. Right, very basic mean calculation. Right, the mean of that data is 15.75. But then it can ask things like the mean mark of 9 pupils on a test is 62%. So 9 students took a test. The average score or the mean score was 62%. A very clever student takes the test a day later and scores 95, right? So they score well above the average. And it says, okay, well, what's the new class average? And so what I do know is if I want to find the new class average, I take 9 students who averaged 62. So I have 9 62s, and then I have 1 95. But now instead of having just 9 students, there's a 10th one. So I'm going to divide by 10. Right? So I take those 9 who averaged 62 and assume they all got 62 because that's what they averaged out to be. Then I add the 1 student who got a 95, this extra student, and then I divide it by the new total, which is 10. And so we end up with 65.3% if we calculate that, right? Which pulled the average up, right? It was an average of 62. Once that one person took the test, it's now 65.3. Right, so mean, right? Mean is the average. Median. Median is the middle of the data. Oh, that's what this says. The median is the middle number, and when you put the data in order. So you put the data in order, and then find the middle number. You use the median when the data has one very small or large value, which would influence the mean, right? Like something like this, we have one that is significantly more than the mean. So maybe instead of using the mean to measure the central tendency, we would use the median to measure the central tendency. That would be a reason to choose median over mean. So here it says, let's find the median. Well, we got to put them in order, 5, 8, 10, 17, 20, and then the middle one is 10, right? So our median for this one is 10. Then find the median of this data. Again, put them in order. So 2, there's another 2, then it goes 4, 4, then 6, 6, then 7, then 8. Right, and so if I find the middle of a longer list, I can kind of cross out as I go. It's not that one, it's not that one. There, left, right. But now I get to this case where there's 2 in the middle. And so if there are 2 data values in the middle, meaning that you have an even number of data points, it's the average of the 2 in the middle. So it's the average, I guess we should say mean. It's the mean of the 2 data values in the middle. And the mean of that is 5, right? But 4 plus 6 divided by 2, 10 over 2, which is 5. So the median, even though that number does not appear in the list, right? 5 doesn't show up anywhere in the list. The median is, in fact, 5. Okay, so then we have the mode. The mode is the most frequent or most common number that shows up in the list. It's the one that happens the most. You would use the mode when you want to find out what happens most often, like if that was your goal to figure out the thing that happens the most, the mode makes sense to use. It can also be used for qualitative data as well as quantitative, right? And so the difference between these qualitative data is data that's words, right? Like something like favorite color, right? We can't count your favorite color. It's yellow, red, green, whatever, versus quantitative data, which are numbers, which would be like the height of everybody in class, right? Like those are numbers. That's quantitative data because they're numbers versus qualitative data, which is words. Yeah, and that's what that says here. For example, if people asked their favorite color, you could say the mode was red. You could say red happened the most often, but you can't find the mean of the colors, or you can't find the median of the colors. That's not possible. Frequency tables. So frequency tables are just a way to organize larger amounts of data. So here it says the following marks out of 8 were achieved by a class. And then the first question is how many students were in the class. And so if I want to figure out how many students were in the class, I can just add up the frequency column. So I'm going to add the frequencies. That's 11, 19, 23, plus 2, 25. So there are 25 students in the class. Okay, we can figure out our totals. That may be a useful thing. There's 25 down here. And then it says, let's find the mean mark. So if I want to find the mean, I have to realize that there were 5 students that got a 4. And so, but I don't want to write 5 students that got I don't want to write 4 5 times and then 6, or write 5 6 times, right? A bunch of 5s. And then add all those up and then divide by 25. And so in order to figure this out, we're going to take the frequency times the mark that you got, which in this case we'll call x. We'll call that x. We'll call that the frequency. If I multiply those together, that means that's a total of 20. This is a total of 30, right? I'm multiplying these. 6 times 8 is a total of 48. And this is 28. And this is 16. And then if I add all those up, so I take that and I sum this column, I get 142. And the reason I do that is because I want the total marks scored all together. So if I take all 25 students and I add up their marks, it is that 142. And I divide by the total number of students that I had, which is 25, which, type that in the calculator, we get 5.68 is the average score, right? The mean mark. This is the mean mark on the test, or yeah, whatever it is. So here it says from above, we can see the rule for finding the mean from a frequency table. X bar is always going to be the sum of f times x divided by the sum. Oops. Okay, remember the sigma is just our shorthand for sum of f. And so what this kind of means in words is it's the sum of the frequency multiplied by the data value, which in this case was the marks. So the sum of frequency multiplied by data value. So I do frequency times data value for each of them, then add them up, divided by the sum of the frequency. I add up all the frequencies, that's how many people or things that there are, and I divide by the frequency, that's what goes on the bottom. Yeah, in sigma notation, that's this, right? Like in words, it's what I wrote over there. And so then here it says, okay, well, what are the median and the mode of this data? The easier one to pick out from this data is the mode. Mode is most common. I see 6 has the highest frequency, so 6 is the mode for sure. Median, I need to do some work to figure it out. The median would happen if there are 25 data points, right? So there's 25 data points. The middle one, right? The middle would be, if we want to think about it visually, there's going to be 12 on the left, 12 on the right, and 1 in the middle. Right, and that 1 in the middle would be the 13th data point. And so I need to figure out, well, what's the 13th data point? If I put them in order, there's 5 of these, plus 6 of those, so I'm at 11, plus 8 of those. So if I add all the 6s, I'm now up to 19. So the 13th data point is in this 6 category, so the median is a 6. Right, and without having to write out the entire list, we can figure out the median. Okay, so everything we've just done is important for us to understand how the statistics work, but we can also do all of these things in our calculators, and we'll quickly talk about them. This is a good reference for you for things to look at, but let's just jump in the calculator and take a look. Everything we've done so far is actually in stats1 variable, even though sometimes there will be, you'll be filling in 2 columns. It's still only one set of data. So let's start over. Let's go to stats1. It'll take you here. If you click symbol, this is a very important thing. The independent column is the thing that you're measuring. So like in the example of the marks question, right, like this one, that would be D1. And then the D2 is either blank. So if it's just a list of data without frequencies, it should be left blank. But in this example of the marks, we had a frequency column. So that should be D2 is going to represent our frequency column. And you notice it says right there, enter frequency, whoops. When you click the box, it says enter frequency column. D2 is going to be my frequency column. So then I can click the table, this num, and enter my marks. So you either got a 4, a 5, a 6, a 7, or an 8. And there were 5 students that got a 4, 6 that got a 5, 8 that got a 6, and 4 that got a 7, and 2 that got an 8. And so I have my frequency column turned on. So if I click stats here on the screen, the stats button, it will take me here, and it will show me a bunch of things. We'll use a lot of these later, but right now we're only really looking for the mean, which we calculated to be 5.68, and the calculator matched that. The median is 6. The calculator does not show you the mode, so that's something you have to look at the data and find yourself, but we know the median was 6, and the mean was 5.6. One very important thing is if you do this, if I type this data in, and I forget to have this on, so I don't have a frequency column on, it will still calculate something, but all it's doing is finding the mean, the median of the first column. And so you'll notice the average is 6. The median just happens to be the same, but the mean is different. The actual mean is 5.68. This is taking only the data from the first column and not considering that there's a frequency column. So if you have a frequency column, you need to make sure that D2 is on in this symbol menu, right? Very, very important. And that's what it's saying down here, right? If you have frequency, enter D2, and then it goes on to explain how to do it. Okay, so the other type of data that we can take a look at is grouped data. So when your data is grouped, you don't know the exact value you have, but you have an estimate of 2 points that it lies between. So you can then find the mean just like you did before. So for example, the following data shows how late trains are arriving at a particular station on a particular day. So it says, let's find an estimate for the mean. So 15 trains arrived between 0 and 5, right? That's what this is saying. 9 trains arrived between 5 and 10 minutes late. 2 trains arrived between 15 and 20 minutes late. So we have all this data. And so what we're going to do is find the midpoint or the average of these intervals. So the midpoint of these would be 2.5, right? In between 0 and 5 is 2.5, 7.5, 12.5, 17.5, and 22.5. Right, the best we can do for fixing these as a number is just grab the middle of them. And so then it says, let's find an estimate for the mean time. And the reason it says estimate is because we're assuming that the midpoint is true, but really all of those data points in the first one could be 5s, but we don't know. So what we're going to go to is stats1 variable. Right, in D1, we're going to enter the midpoints, what we have written over there. In D2, you can enter the frequencies. Right, and then you need to make sure D2 is on in the symbol button, right? So make sure that D2 is turned on. Take a second, pause the video, go enter this for D1, go enter this for D2, click stats on the screen, and see what you get. When you do that, X bar, the mean, ends up being 7.34 minutes, right? That was the average length of delay, right? Like when trains were late, that was the average one. And so then something you can also see is which is the modal group. We kind of see the word mode in here. It's not called the mode because it's a group of data. So which group of data was the most common? Well, it's this first one. The modal group is 0 to 5 minutes. That was the most common amount of time that people were late. All right, in this example here, it says 79 students took a test and their scores were recorded below. So we know the total frequency is 79, they tell us that, right? The frequencies should add up to 79. And they're put into these different categories, right? So 15 students scored between a 21 and a 30, right? That's what that means. And so it tells us to do a couple things. It says find the mean of the data. And so in order to do that, they kind of left us this box here that we could put the midpoint in. And so the midpoint between 1 and 10 is 5.5, right? Like 1 plus 10 divided by 2 is 11 over 2, which is 5.5, right? So they're all the 5.5s. It's not 5. It's not 0 to 10. That would be 5. 11 to 20 would be 15.5, 25.5, 35.5, 45.5, 55.5, and 65.5. So at this point, I can go to the calculator, right? Again, I'm going to go to stats1 variable. I'm going to enter D1 and D2, where D1 is my scores, the midpoints, right? That's D1. Over here is D2, the frequency. I need to make sure that the frequency is on in the symbol, right? So just reminding ourselves that when we do go to stats1, if I have a frequency column like I do in this example, I have to make sure this D2 is on here. Yeah, and I can go calculate the mean, median, all these things, right? So A says find the mean. So X bar, the mean is 34.2. If you take the time to type it all in and click stats. B asks you for the modal class. The modal class is the one that's most common, which is this one. So it's 31 to 40. Right? 31 to 40 is where the most grades were, right? And then the last part, it says find in which group does the median lie. So the median group will again be one of these groups. We have to figure out which one. So in total there are 79, right? And so that means that if I have 79 data points, that means that there will be, if I do 39 over here and 39 over here, that's a total of 78. And then there's one that sits in the middle. So I'm looking for the 40th data point is the median. And so I kind of have to add up as I go and figure that out. So I have to say, okay, well, that's 14. 14 plus 15 is 29. And then 29 plus 25 gives me 54. So the 40th one happens in this group, right? By the time you get to the end of this group, you're at 54, so you're beyond it. So the median group is also in there, right? So the median is somewhere between 31 and 40. Right, so again, our grouped data, finding mean, modal class, median. All right, standard deviation. So standard deviation is just a measure of how spread out the data is. Okay. And so the interquartile range, which is maybe something we remember, the third quarter minus the first quarter of the data, is a good measure of how spread the data is. Particularly because, like the median, it's not affected by the extreme values, right? So like if you do Q3 minus Q1, if you have some really big outliers or some really small outliers, they don't affect that as much. In this situation, we're going to use standard deviation, and this can be thought of as the average distance of the data from the mean. That's what this is saying. The average distance of the data from the mean. So what it's doing and how it's calculating it is, we define there's two things. There's variance and standard deviation, and they are very much connected. Variance is just the standard deviation squared, right? So this is an important thing to get. Variance is equal to standard deviation squared. That's the connection between those two. They use this lowercase sigma, right? This symbol is a lowercase sigma. That's the letter that it's using. And so this symbol means standard deviation. This symbol means variance. Variance, right? So sigma alone is standard deviation. Sigma squared is variance. And so what it's doing is it's finding the x value of your data point. It's subtracting the value of the mean. It's squaring those things so that it doesn't matter if it's positive or negative or above or below the mean. And then it's adding them all up. So it's finding the total distance each individual point is away from the mean. And then it's dividing it by the total number of points that there are. So it's finding the average distance from the mean. And the variance is finding the average squared difference. But the standard deviation is the square root of that. So it's the average distance, right? So standard deviation is your average distance from the mean. The symbol for standard deviation in the calculator, it is the same symbol, but then there's an X after it. And so the words for it are population, standard deviation, which we'll look at in a second in the calculator. Like that's what it will say in there in the calculator. There is also this other one that says standard deviation, which is a capital S and an X. It is not that one, right? That's something that we'll learn later. We will use that, but that's not for this unit, not for right now. So here it says, okay, well, here's some data. This data represents test scores. Find the standard deviation and the variance. So we're going to go take all this data and go put it in stats1 variable in D1. Right, so let's just do that quickly because it'll be worth clear everything there, clear all. 1, 1, 2, 4, 4, 5, 6, 8, 9, 9. And so if I click stats right now, it's going to tell me there's an error. And the reason it's telling me if there's an error is the last time I did a calculation, I had a frequency column. This time I do not. So I have to go back to symbol and tell it I no longer have a frequency column. I just have a list of raw data. They're not set in a frequency table. So I'm going to get rid of D2, delete it, and click stats. And it will calculate all the things we think. There's the mean. And so this is where you'll see the standard deviation. You'll see there's this SX, which I said is not it. That's the sample standard deviation. The one we want is this one called population standard deviation, and it's 2.91. So the standard deviation is 2.91. And the variance, which is this symbol, is just that thing squared, 2.91 squared, which is 8.49 if we square it, right? So standard deviation, 2.91, variance, 8.49. So then it says we can do the same thing with, if we do have a frequency table, we can take this data and we can say, well, let's find the midpoints. And these are 2.5, 7.5, 12.5, 17.5, and 22.5. This is going to be our D1 because those are the times, right? Like these are times in minutes. And this is going to be D2 because that's our frequency. And so we can go enter that. So let's go back to our data. We can clear all the things that are there. We said 2.5, 7.5, 12.5, 17.5, and 22.5. And then I do have a frequency column, so 8, 11, 16, 12, and 5. And so if I click stats now, notice there are only 5 items, which is not true. There's way more than 5. If I add up the frequency, there's a lot more. The reason that it's doing this is because I did not turn the frequency column on. So I have to go back to symbol. I have to tell it that there's a frequency column. That column is D2. Click OK. Then I go back to my table. I can click stats. And I notice, oh, now there's 52, which is correct. And so I can find the mean, right? The mean of this data is 12.0. The standard deviation is that one, 5.99, right? If we were to round it to 3 significant figures. So standard deviation, which is this symbol, is 5.99 for this data, right? That's how spread out the data is. The average distance from the mean is 5.99. All right, the last thing for this unit is to look at this idea of constant change. So it says find the mean and the standard deviation of these things. To save us some time, you can type those in. You could do it yourself just to check that you know how to do it. But X bar is 5.67 and the standard deviation is 2.98. And then it says, okay, we'll now go find the standard deviation of that. And so if I look at this group compared to this group, these are 10 more. Each value has been added plus 10. And so what that means for the mean is it will shift the mean up 10. But if you go type that in and find the standard deviation actually stays the same. So adding a constant amount only affects the mean. So then let's look at, well, what happens with this? How does this compare to our original one? This one and this one, I notice, oh, they all have an extra 0, so it's times 10. And if I find the mean of this one, it's going to be 56.7, which is 10 times as big as the original. And the standard deviation will be 29.8, which is also 10 times the original. So I notice addition only affects the mean, but multiplication affects both the mean and the standard deviation. And so then what happens if I have a combination of 2 of those? So these are created by multiplying by 10 and then adding 4. Right? If I take each individual element and I multiply by 10 and then I add 4 to it, I'll get this last list. And so to find this one, it's going to be 5.67. So I will multiply this by 10 and then add 4 to it to find the new mean, which is 60.7. But we said standard deviation is only affected by multiplication. So 2.98 times 10, but not plus 4. That plus 4 doesn't change the spread of the data, it just changes where it is. And so this is 29.8. Right, and so to summarize, adding and subtracting affects mean only. Multiplying and dividing affects both mean and standard deviation. Right, so it affects both of them when you multiply and divide.